All right, kicking off another deep dive. This time, we're all about 3D vision and stereo vision.
Yeah, it's tech that's everywhere these days.
Seriously, from those self-driving cars everyone's talking about to the newest VR games.
Exactly.
I figure, maybe some folks listening are getting ready for a presentation or
Mhm.
trying to stay ahead of the curve in their field, or maybe
Yeah.
they're just curious about this stuff, like how it all works.
Right, right.
Well, we've got a whole bunch of sources that honestly make learning about this stuff pretty fun.
Yeah, and we're going to break it down so it's easy to get. We'll hit the main ideas,
Yeah.
see where it's actually being used out in the world,
Yeah.
and hopefully even have some aha moments along the way.
All right, so let's jump right in. First things first, what exactly is 3D vision?
Okay.
I get that it's, seeing things in 3 dimensions, but what makes it different from just, like, looking at the world normally?
It's all about adding that extra depth, that context to what you see. Think about a regular photo. It's flat, two dimensions.
Yeah, yeah.
But 3D vision, a system using that can look at a scene
Uh-huh.
and figure out how far away things are, which way they're facing, the whole 3D layout.
Okay.
It's not just a snapshot. It's like having a detailed map.
So it's not just seeing in 3D, it's like the system actually understands the 3D space.
Exactly. It gets the whole picture. And one of the coolest ways to do this is through stereo vision,
Stereo vision.
which, by the way, is kind of how we humans see depth, too.
Ah, is that like those old school 3D glasses, the ones with like the red and blue lenses?
Basically, you have two different viewpoints, just like our eyes.
Right, right.
Each view captures a slightly different image.
Okay.
And by looking at the differences,
Okay.
the system figures out the depth.
Okay, I'm kind of starting to get it, but
Yeah.
can we break it down like step by step?
Sure.
How does stereo vision turn two regular images into like a full 3D understanding?
All right, so there's a four-step process. First, you got to have two cameras, like our eyes, spaced a bit apart.
Got it. So image capture, step one, check. What's next?
Next comes what's called pixel matching.
Pixel matching.
Yeah, a smart algorithm looks at both images
Okay.
and finds the matching points, basically the same point in the scene, but from those two different angles.
It's like a super high-tech game of spot the difference.
Huh, pretty much. And from those matching points, the algorithm calculates something called disparity.
Hold on, disparity, that's a new one.
Okay, think of it this way. The bigger the difference in position between those matching points, the closer the object is to the cameras. Big difference means close, small difference means far away,
Okay.
and that disparity info, that's the key to figuring out the depth.
So we've got our two images, we've matched up the points, figured out the disparity. What's the last step?
3D reconstruction.
Ooh, that sounds cool.
Using the disparity and some geometry, based on how the cameras are set up,
Right.
the system can actually rebuild the entire scene in 3D.
It's like those 3D models you see, like of cities or landscapes.
You got it. And that's just one example, really.
Oh, wow.
Stereo vision is being used in so many places.
Really?
Self-driving cars use it to see and navigate, robots to handle objects precisely, even in VR and AR to make the experiences more real.
So this isn't just like research lab stuff. It's being used right now.
Oh, yeah, absolutely. It's popping up everywhere. Take self-driving cars, for example.
Okay.
Stereo vision helps them see obstacles, figure out how far away they are, and make safe driving decisions.
Whoa, so the car can not only like detect a person, but also tell how far away they are.
And how fast they're moving.
That's crazy. It's not just avoiding accidents. It's like making those split-second judgments that human drivers make all the time.
Exactly. Exactly. And that same depth perception is changing robotics, too. Think about robots in factories putting together delicate parts,
Right.
or even those surgical robots doing incredibly precise movements.
Yeah, yeah.
Stereo vision gives them the spatial awareness they need to do those things.
Okay, my mind is officially blown.
Uh-huh.
But you were talking about those 3D models, like of cities and landscapes before.
Right.
Is that stereo vision too?
It is. Those super detailed models often use data from drones or even satellites,
Uh-huh.
all equipped with stereo vision systems.
Wow.
Archaeologists use it to recreate ancient sites.
Real.
City planners use it to design new stuff. And we use it to make those hyper-realistic virtual worlds in video games and movies.
Okay, now I really see why this tech is such a big deal. And what about VR and AR? How does stereo vision make those experiences like more real?
Well, think about it. Most VR and AR systems track your head movements,
Yeah.
so you can look around in a virtual environment.
Right. Right.
But what if you could reach out and actually touch a virtual object?
Oh, wow.
Stereo vision makes it possible for these systems to accurately show depth, so virtual objects actually feel solid, more real. You can even use your hands to interact with them
Right.
in a more natural way.
Okay. Okay. Enough about the applications. My brain needs a break.
Uh-huh. All right.
Let's talk about how the magic happens behind the scenes. What
Sure.
kind of algorithms make all this possible?
Well, there are a bunch of different ones, each with its own strengths and weaknesses.
Okay.
One of the simpler ones is called block matching. It breaks the images up into little blocks of pixels
Mm.
and then compares them to find matches.
Kind of like a jigsaw puzzle, but with pixels.
Pretty much. But what if you need that depth perception in real time?
Right, like for a self-driving car that has to react super fast.
Exactly. For that, you need algorithms that can do the math really quickly. That's where real-time disparity search comes in.
So like block matching, but on fast forward.
Hmm. Exactly.
Here.
But sometimes you need even more accuracy, especially when you have a really complex scene. That's where something called semi-global matching, or SGM, comes in. It looks at the whole picture, not just individual blocks.
So it takes everything into account.
Right, and that gives you more accurate results, especially in tricky lighting or with subtle textures.
Wow, it's amazing how each algorithm has its own specialty.
Yeah.
You mentioned neural networks before too.
Mm-hmm.
Are those used in Stereovision as well?
Oh, yeah. They're becoming more and more popular because they can learn and adapt way better than traditional algorithms.
Interesting.
They can be trained on huge data sets of images
Yeah.
and learn to spot patterns and make really subtle judgments about depth.
It's like they're the super learners of the algorithm world. I bet they're being used for some of the coolest new applications.
Definitely. Neural networks are really pushing the boundaries of what's possible with stereo vision.
Yeah.
They're improving accuracy in difficult conditions and even speeding up processing.
All right, my brain is officially fried. This is way cooler than I ever thought.
It is pretty remarkable, and it's just getting started, really.
Yeah.
Who knows what we'll see in the next few years?
Right. Okay, before we get lost in the future,
Uh-huh.
let's take a step back.
Okay.
What are the advantages and limitations of stereo vision right now, like today?
Good point. Let's start with the good stuff. One of the biggest advantages is that stereo vision is really accurate at perceiving depth.
Like we were talking about with the cars and the robots, that precision is key.
Exactly. Another plus is just how many applications it has, like we've been discussing. It's showing up in almost every industry: transportation, manufacturing, healthcare, entertainment.
Okay, but what about cost? Is this only for big companies and research labs?
Actually, compared to some other 3D sensing tech, stereo vision is pretty affordable.
Really?
It mostly relies on cameras and software,
Right.
which are getting cheaper all the time as technology keeps improving.
So it's powerful and affordable. That's a great combination.
Yeah.
But you mentioned limitations earlier. What are some of the things that trip these systems up?
Well, one challenge is that the cameras need to be lined up perfectly.
Like perfectly.
If they're even a tiny bit off, the depth calculations can get messed up.
That makes sense. It's like trying to judge distance with one eye closed. It just doesn't work as well.
Right. Another challenge is low contrast scenes.
Okay.
When there's not much variation in color or brightness, it's hard for the algorithms to find those matching points.
Yeah, like trying to make out shapes in a dense fog. It gets tricky.
Exactly. And distance plays a role too. Stereo vision systems work best within a certain range.
Like a sweet spot.
You got it.
Okay, so what happens if objects are too close or too far away?
Well, if they're too close, the difference in the images becomes too big to measure accurately. And if they're too far away, the difference becomes too small to even notice.
So it can't tell how far away a mountain range really is.
You would have a tough time. But researchers are working on overcoming these limitations.
Oh, good.
They're developing new algorithms and techniques that can handle tougher conditions.
That's awesome. This has been an incredible overview. I feel like I've gone from knowing nothing to at least understanding the basics of 3D vision and stereo vision.
I'm glad to hear it. It's definitely a fascinating field.
And we'll be exploring more in part 2 of this deep dive. We'll be checking out the cutting edge research and talking about what this means for society as a whole.
Definitely. We'll be discussing the challenges that researchers are still working on,
Yeah.
how stereo vision is changing different industries, and maybe even some potential for even more amazing applications in the future.
So stay tuned for part 2, where we'll continue our journey into the world of 3D vision and stereo vision.
See you then.
All right. All right, welcome back to our deep dive into 3D vision and stereo vision. Last time we got into the basics.
Yeah, how stereo vision basically copies how we humans see depth.
Right. And how it uses that to create a 3D understanding of the world.
Exactly.
We saw how it's being used in everything, self-driving cars, those super detailed 3D models of cities and landscapes. It's pretty amazing stuff.
It is. We talked about how Stereovision uses two different viewpoints to capture slightly different pictures.
Right, and then those clever algorithms come in and analyze the differences to figure out like how far away things are.
Exactly.
But we also talked about some of the limitations, like needing to perfectly align the cameras.
And how low contrast scenes can be a problem.
Oh, and the fact that these systems work best within a certain range.
Right, right. Not too close, not too far.
So now I'm really curious about like what are the frontiers of this tech? What are researchers working on to like overcome those limitations and make it even more powerful?
Well, one of the biggest challenges is dealing with what we call dynamic environments.
Dynamic environment.
Yeah, basically scenes where things are constantly moving,
Oh, okay, I get it.
like a busy street with cars and pedestrians going every which way.
Right, right.
A lot of the current algorithms have trouble accurately estimating depth when there's that much motion.
It's got to be like trying to take a clear picture of like a moving target.
Yeah, you get that blur.
Exactly.
But don't worry, researchers are coming up with new algorithms that can handle those moving targets, so to speak.
Oh, cool. How do they do that?
They're starting to incorporate what's called temporal information.
Temporal information.
Basically, it means analyzing a bunch of images taken over time
Hmm.
instead of just individual snapshots.
So instead of just looking at one frame, they're looking at how things are moving from frame to frame.
Exactly. And that helps them create more accurate depth maps, even when things are moving around.
Wow, that's really impressive. It's like those time-lapse videos where you can see like a plant growing or clouds moving across the sky.
Exactly. By tracking how things change over time, you get a much better understanding of what's going on in the scene.
That makes sense. So dynamic environments, that's one big challenge. What else are researchers focusing on?
Another big area is robustness,
Robustness.
making the systems more reliable, less likely to make mistakes.
Okay.
Right now, things like changes in lighting, shadows, even reflections can mess up the calculations.
Yeah, I can see how that would make it tough to see things properly.
Right. So researchers are trying to make algorithms that are more adaptable,
Mhm.
that can handle those variations. Some of them are even using machine learning
Oh, wow.
to train the system on tons and tons of data.
So it learns from experience.
Exactly. The more data it sees, the better it gets at handling those unexpected situations.
That makes sense. So we've got dynamic environments, robustness.
Yeah.
Anything else where researchers are really pushing the limits?
Computational efficiency is another one.
Computational efficiency.
Some of these algorithms can be pretty demanding. They need a lot of processing power and memory to work.
Especially if they're working with like high resolution images or videos, right?
Exactly. So researchers are working on making these algorithms more efficient so they can run on things like smartphones or drones.
God, that would be huge. It would open up so many possibilities for like mobile apps. Imagine you could use your phone to create detailed 3D models of your surroundings.
Exactly. Or drones with Stereovision could navigate through tricky environments all on their own.
Okay, hold on. I need a minute to process all of this. It sounds like we're on the verge of some major breakthroughs.
It's pretty exciting stuff. But let's zoom out for a second.
Okay.
We've talked a lot about the technical stuff, but what about the bigger picture? How is this changing the world around us?
Yeah, that's a good point. We touched on some of the applications, but I'd love to hear more about how different industries are being impacted.
Well, transportation's a big one, like we said before.
Right, with the self-driving cars.
Yeah, but it's not just that. Stereovision's making other forms of transportation safer and more efficient too.
Like what?
Well, it's helping trains detect obstacles on the tracks,
Oh, wow.
and it's helping pilots with things like landing and taxiing.
So it's not just about making transportation autonomous, it's about making it smarter and safer overall.
Exactly. And it's not just transportation. Manufacturing's changing too.
Hmm.
We talked about robots using it for precise tasks, but as this tech improves, we'll see even more advanced robots that can handle more complicated jobs.
You mean like robots that can actually work alongside humans?
Exactly. Robots with advanced stereovision will be able to see what's going on around them and interact with people in a more natural way.
That's incredible. It sounds like it could totally revolutionize the way we work. What about healthcare? We talked about medical imaging before, but are there other applications?
Definitely. Surgeons are using these systems to get a 3D view during surgery,
Oh, wow.
so they can work with much more precision.
Okay.
Physical therapists are using it to track patients' movements during rehab,
Hmm.
so they can give them feedback in real time and help them recover better.
So it's not just about diagnosis and imaging, it's about improving the whole healthcare experience.
Exactly. And let's not forget about entertainment.
Right.
We mentioned VR and AR, but stereovision's also being used to make things more immersive and exciting in
Yeah.
everything from video games to theme park rides.
I need to get my hands on some of these new VR games. It sounds like they're taking things to a whole new level.
They really are. By making these virtual environments feel more real, stereovision is really starting to blur the lines between what's virtual and what's real.
This is so cool. It's clear that this is a really powerful tech that's going to affect all of us.
I completely agree. And as the technology keeps improving,
Yeah.
we can expect even more amazing applications and a big impact on how we live, work, and interact with the world.
This has been an incredible journey so far. We've gone from the nuts and bolts of how Stereovision works to seeing all of these mind-blowing applications.
It's been a great conversation.
But we're not done yet. In part 3, we're going to dig into some of the bigger societal impacts of this technology.
Yeah, the potential benefits and challenges of it becoming widespread.
So stay tuned for the final part of our deep dive, where we'll wrap things up and give you some things to think about.
Looking forward to it.
And we're back for the final part of our deep dive into 3D vision and stereovision. We've covered so much ground, from the nitty-gritty technical details to all the amazing applications that are popping up everywhere.
It's been quite a ride, from self-driving cars to healthcare, entertainment. It seems like this tech is transforming everything.
It really is. But now I'm thinking about the bigger picture, As this tech gets even more powerful, more common, what does that mean for society? What are the big implications we should be thinking about?
That's the million-dollar question, isn't it? Like any really transformative tech, stereovision has incredible potential, but also some potential downsides. One area that's super interesting to me is how it might affect, like, human perception and cognition.
What do you mean by that?
Well, think about it. As we rely more and more on machines to, sense the world and make sense of it, is it possible our own abilities could start to weaken?
Like, could we get lazy?
Exactly.
Yeah.
Imagine a world where self-driving cars are so normal that people hardly ever drive themselves anymore.
Yeah.
Would our spatial awareness, our reaction times, would those suffer?
That's kind of scary thought. Like those sci-fi movies where humans get so dependent on tech, they forget how to do basic stuff.
It's definitely something to keep in mind.
Yeah.
But on the other hand, stereovision could also enhance our perception in ways we can't even imagine yet.
Oh, interesting. How so?
Well, think about AR systems that could overlay digital info on top of our real-world view,
Right.
giving us real-time insights and guidance.
Yeah.
Or accessibility tools that could help people with visual impairments navigate the world more easily. Stereovision could really empower us to see and understand our surroundings in totally new ways.
That's an awesome perspective. It's like giving humans superpowers.
In a way, yeah. But it all comes down to using this tech responsibly, ethically.
Speaking of ethics, are there concerns about, like, stereovision being misused?
Absolutely, that's a big one.
Yeah.
Like any powerful tool, it could be used for things that aren't good for society.
Like, what kind of misuse are we talking about?
Imagine surveillance systems that could track people's every move with crazy accuracy.
Oh, yeah.
Or autonomous weapons that could make life or death choices without any human input.
Whoa.
Those are some serious issues we need to be talking about.
Definitely. It sounds like we need to be having some serious conversations about the ethical limits of this tech.
Absolutely. We need clear rules, regulations to make sure stereovision is used for good, not for harm.
It's a good reminder that with any tech advancement comes the responsibility to use it wisely.
Couldn't agree more. It's not just about what the tech can do. It's about the choices we make and how we develop and use it.
Well, this has been an incredible journey into the world of 3D vision and stereovision. I feel like I've learned so much, not just the technical stuff, but also all the bigger questions it raises.
It's been great discussing it with you. I hope our listeners are feeling the same way.
I hope so too. Before we go, I want to leave our listeners with one last thought. We've talked about all the amazing possibilities of stereovision, but also the potential risks. So here's a question for you to ponder. As this tech keeps evolving, what role do you want to play in shaping its future?
That's a great question to leave everyone with. We're all part of this, and it's up to each of us to stay informed, be part of the conversation, and help make sure stereovision is used to create a better world for all of us.
Well said. And on that note, we'll wrap up this episode of The Deep Dive. Thanks for joining us on this incredible adventure.